So it is 3 a.m.
Oh, the classic hour for deployment.
Right.
Well,
Always. And you are just staring at your monitor. You're operating on purely caffeine and like sheer spite at this point.
yeah, we've all been there.
I mean, you've spent the last 3 weeks architecting this massive cloud deployment for a major project. Your code is flawless.
Yeah.
You've run local tests. Everything passes.
Of course it does.
Right. So you take a deep breath, you hit the execute button to deploy to AWS, and suddenly the system throws this massive, unyielding brick wall right in your face. A deployment failure.
Which is just the worst feeling.
It really is.
Yeah.
So you start digging, completely convinced you must have missed a semicolon or, I don't know, misconfigured a routing table somewhere.
And that right there, that is the ultimate psychological trap of cloud computing.
What do you mean?
Well, we operate under this default, deeply ingrained assumption that every failure we encounter is a technical bug. Like, we immediately blame our code, our logic, or, our architecture.
Yeah, because usually it is our fault.
Usually. But sometimes the code is perfectly fine. The systems administration is the actual culprit.
And today, we are going to rescue you from that exact 3 a.m. nightmare. We are doing a deep dive into a really fantastic piece. It was published today, actually, June 12, 2026.
On tech-reader.blog, right?
Yes, tech-reader.blog. Software engineer Aaron Rose wrote this incredible breakdown of one specific, deeply obscure roadblock. It's called the Amazon S3 account problem error.
It's a notorious one.
Oh, yeah. So our mission for this deep dive is to hand you the ultimate shortcut so that the next time this wall appears, you can just bypass all the agonizing troubleshooting completely.
I love that mission because to really appreciate the solution here, we have to look at why this specific error is so, well, uniquely devastating to a developer's workflow.
Because it doesn't look like a normal error.
Exactly. It completely breaks the pattern of standard feedback. When you work with a massive cloud storage service like Amazon S3, you are trained to look for very specific, logical error messages that point to technical fixes.
Right. And the article highlights the two most common ones you'll see. First, there's access denied. And I mean, as a developer, you know exactly what that means. You're trying to read or write a file, and the system looks at your credentials and basically says, nope, you weren't on the guest list.
Yeah, it is a very straightforward permissions issue.
Yeah.
The system recognizes your identity, but the specific policy attached to your user profile just lacks the necessary privileges for that specific action.
So you just go in and fix the JSON policy.
Fix the JSON, and you're in. Simple.
And then there is no such key, which is, really just AWS's fancy cloud terminology for a 404 error.
Exactly, file not found.
Yeah, you're knocking on a door that simply doesn't exist.
Yeah.
Maybe you made a typo in the file path or the file was deleted. But again, it is a technical problem with a technical solution. You fix the path, resubmit the request.
Right, but then out of nowhere.
Out of nowhere,
Yeah.
you get hit with an HTTP 403 error that just says account problem.
What's fascinating here is the underlying psychology of that specific message and why it catches people so off guard. AWS isn't evaluating your code at all.
It's not even looking at it.
Nope. It isn't checking if the file is missing or if your user role is configured correctly. It is signaling a full administrative stop sign.
Meaning what exactly?
It means AWS cannot even begin to process the technical request because the AWS account itself requires intervention.
Okay, let's unpack this with a real-world scenario.
Yeah.
Think of the AWS infrastructure like an exclusive nightclub.
I like this analogy.
Right, so access denied is the bouncer at the front door checking your ID and telling you that you aren't on the VIP list. And no such key is getting inside, asking the bartender for a very specific vintage wine, and being told they are completely out of stock.
Makes perfect sense.
But account problem. That is like showing up to the club and finding out the city government has padlocked the front doors because the owners didn't pay their property taxes.
That captures the architecture perfectly. I mean, the key you are holding works, the VIP room exists, the wine is in the cellar, but the overarching ownership layer has shut the entire building down.
The building is just closed.
Yeah, the infrastructure is completely subservient to the administrative state.
Okay, but I have to challenge the developer mindset here, though. If it's a completely different category of error, why does Aaron Rose call it a common mistake that people spend hours trying to fix it in their code?
That's a great question.
Like, why are we so conditioned to blame ourselves and immediately start tearing apart our IAM roles?
It really comes down to muscle memory. That and just the sheer statistical probability of standard errors.
Because 403 usually means something else.
Yeah, a 403 HTTP status code universally means forbidden. And 99 times out of 100, when a developer sees forbidden, it means they messed up their identity and access management policies.
Ah, so they panic and rush to the IAM dashboard.
Exactly. They start tweaking JSON files, adjusting user privileges, totally convinced they just haven't granted the right read or write access to the S3 bucket.
And you can spend like 6 hours going down that rabbit hole, assuming you just formatted a single permission tag incorrectly.
Oh, easily. And you will never fix it. Because account problem points to an account level issue, not a permissions issue.
Right.
Your credentials can be perfectly valid, your IAM policy is flawlessly constructed, but the request is going to fail anyway.
Wow. So since we've established that the code might be an absolute masterpiece and the permissions are spotless, we really have to look at what is actually pulling the plug at that macro level. What is the administrative reality triggering this?
Well, the source outlines several specific non-technical triggers. Billing issues are usually the primary culprit.
Like an expired card.
Yeah, a credit card expires, or maybe a bank flags a recurring charge as fraud. Then you also have suspended accounts or incomplete account verification.
Oh, like when you forget to click the email link?
Exactly. Maybe a team member set up a new AWS environment, but just skipped that final email confirmation step.
The article also mentions AWS administrative restrictions, which could be tied to suspicious activity and internal account status problems that haven't fully resolved.
Right. And when you synthesize all of these triggers, you start to see this really hard boundary in cloud computing. We often forget that beneath the virtualized servers and the infinite storage, there is an actual business contract.
A financial agreement.
Yes. And if the business layer says halt, the technical layer immediately goes dark. No amount of brilliant engineering can override a declined credit card.
Okay, but let me push back on the platform's design for a second here.
Go for it.
If the issue is simply that my company's credit card expired, why doesn't the S3 error just explicitly say, hey, your credit card expired?
I know, it's frustrating.
Isn't it a massive flaw in how AWS communicates with developers to hide a mundane financial issue behind a cryptic HTTP 403 account problem tag?
That frustration is entirely valid, honestly. But the design is actually intentional. It comes down to security architecture and what we call the separation of concerns.
How so?
In AWS, the system generating the error, which is the S3 storage data plane, doesn't actually know why your account is flagged.
Wait, really? It doesn't know?
No, it doesn't. It only communicates with the control plane, which simply hands down a binary revoked status.
So the S3 bucket is essentially in the dark. It just knows it's not allowed to talk to you anymore.
Precisely. Furthermore, from a security standpoint, you would never, ever want a public-facing API exposing sensitive corporate business information.
Oh, right.
Imagine if an external user triggered an error and the API responded with, "This enterprise's corporate credit card was declined for insufficient funds."
Oh, wow, yeah. That would be a massive information leak.
Exactly.
Wow.
So AWS provides a generic administrative flag to protect the business state.
Basically saying, we can't tell you what's wrong, but you definitely can't come in.
Yeah, that's it.
It's maddening. But, I mean, understanding that boundary tells us exactly what not to do. If we know we shouldn't be digging around in S3 bucket configurations or IM.json files, where exactly should you direct your attention to find the actual answer?
Well, the author provides a very targeted investigative toolkit for this exact moment. And step one is actually the hardest for an engineer.
Which is?
Completely exit your code editor. Close the S3 backboard.
Just walk away from it.
Walk away. You need to log into the AWS Management Console, which is the administrative hub.
Right. And the checklist Aaron provides says you need to hunt down 4 specific areas: billing notifications, account alerts, the AWS Health Dashboard messages, and administrative notices.
The AWS Health Dashboard is really critical here. It acts as the operational communication channel where AWS explains the actual why behind account-wide restrictions.
There is also this detail in the article about checking the root account email that feels like a massive trap for larger teams.
Oh, it's a huge trap.
Just to clarify, the root account is the email address used to originally create the AWS environment, right?
Yes, it is. And that structural detail causes immense friction. Often, critical warnings, like a notification that payment failed or a demand to verify corporate identity, they are only sent directly to that root email address.
So if you are a senior developer or an external contractor working under a sub-account,
Or an assumed IAM role, yeah.
you have zero visibility into that inbox.
Zero.
Oh, that paints a painful picture. I mean, you are banging your head against the wall at 3 a.m., debugging perfect deployment scripts, and meanwhile, the CEO or the IT director has an automated email sitting unread in their spam folder saying the entire AWS account is paused.
It happens way more often than anyone wants to admit. There is also another crucial, seemingly obvious step the source highlights that catches veterans all the time.
What's that?
Verify your credentials. Like, confirm you are actually using the expected identity.
Oh, I see. So if you are an agency juggling multiple client projects, your terminal might just be authenticated to the wrong profile.
Yeah.
You are trying to access client A's S3 bucket using client B's credentials. And if client B happens to have an account problem because their billing lapsed, you are getting an error that makes absolutely no sense for the project you think you're deploying.
If we connect this to the bigger picture, the root cause of an S3 failure is entirely invisible within the S3 service itself. This really underscores the vital importance of holistic cloud governance.
You can't just know the code.
No, knowing how to write elegant code is only half the battle. You have to know where your administrative dashboards live and how the underlying infrastructure is governed.
Here's where it gets really interesting, though. Think about it like tearing apart your car looking for your lost wallet.
How?
You're checking under the floor mats, you're digging the glove box, pulling up the seats, just utterly convinced it has to be in the car. But in reality, you left it on the table at the restaurant 3 miles away.
Right.
You are exhausting yourself searching a space where the solution simply does not exist.
That analogy hits the nail on the head. You have to know when to stop searching the car and call the restaurant.
Okay, but let's play devil's advocate for a second. Let's say you do all of that. You stop searching the car. You log into the management console. The billing looks fine. The health dashboard is showing green across the board. The CEO's root email is totally empty of warnings, and you double-checked your terminal credentials.
Okay, a perfectly clean slate.
Exactly.
Bruh.
But you hit deploy, and the 403 account problem error is still there. The invisible wall hasn't moved. What is your next move?
Well, the source material is very clear on this final escalation. You have to contact AWS support.
Which is, let's be honest, the absolute last thing any developer ever wants to do. We want to automate everything, not open a support ticket and wait.
I totally understand the reluctance, but the blog explicitly notes that AWS support possesses visibility into internal system states that users simply cannot access.
Like what kind of states?
They can see if a manual account verification process got stuck in a pending state on their servers. They can identify internal administrative flags that maybe haven't propagated to your user-facing dashboard yet.
So you're saying there are account-level conditions that literally cannot be diagnosed from the S3 error messages or the administrative dashboard?
Yes,
We are flying completely blind to them.
we are. And this raises an important question about transparency in modern tech infrastructure. We rely on these massive, highly automated, hyper-scaled platforms to run our businesses.
Yeah, we trust them completely.
But ultimately, there are opaque internal states within these corporations that can take your entire project offline without leaving a single visible paper trail for you to follow. You are essentially forced to rely on their human support team to act as an interpreter for their own system.
The irony there is just staggering. I mean, the entire premise of cloud computing was built on giving users total, automated, frictionless control over their infrastructure. We don't want to wait for physical server racks to be installed anymore. We just click a button and spin up a supercomputer in Tokyo.
Right. Instant gratification.
Yet, when something goes wrong deep within their internal state, we are reduced to the most manual, old-school stack imaginable. Calling customer support. It feels like a massive regression.
It is the paradox of scale. These distributed systems are so impossibly complex and so heavily automated that when a rare edge case administrative error occurs, the automated diagnostic tools just fail to capture and translate it accurately for the end user.
Now, Aaron Rose's focus here is clearly on rescuing developers from this wasted effort. It's really about optimizing your time. And if you look at the surrounding context of tech-reader.blog, this isn't just an isolated tip.
No, not at all.
It reveals a broader philosophy of efficiency that we can apply to all of our tech projects. We could almost call it curing infrastructure blindness.
That's a really great way to frame it. tech-reader.blog uses the tagline, "Technology Learning Made Simple." And a recurring theme across their content is lean, optimized computing.
Knowing your limits.
Yes. It is about understanding the hard boundaries of your environment, whether those boundaries are administrative, like we just discussed, or physical hardware limits.
Let's actually look at some of the other edge case tech articles surrounding this piece to see how that philosophy applies elsewhere. There's a deep dive comparing Diet Pi versus Raspberry Pi OS Lite for headless servers.
Oh, this is a classic debate for engineers building IoT devices, Pi-holes, or home media servers.
Right, because resources are so tight.
Exactly. The entire goal there is avoiding software bloatware. When you are working with a micro SD card that only has a few gigabytes of storage and a processor with tight thumb limits, every single megabyte matters. The article really contrasts the familiar comfort of Raspberry Pi OS Lite with Diet Pi's aggressive, stripped-down optimization.
You really have to know exactly what processes your system is running. And they take that same approach to hardware limitations, too. There is another fascinating article exploring the reality of running AI models on the Raspberry Pi 5.
Yeah, they specifically look at the flagship model, right? The one with 8 GB of RAM and the quad-core Cortex-A76 processor.
Exactly. And on paper, those specs look incredibly promising for a hobbyist. A 2.4 gigahertz processor with LPDDR4X RAM offering vastly improved memory bandwidth.
It sounds like a total edge AI workhorse.
Right, but the article forces the reader to look past the raw specs and understand the architectural reality.
Because raw CPU speed doesn't automatically equal specialized hardware acceleration.
Bingo.
The Cortex-A76 is a great general-purpose CPU, but it lacks dedicated neural processing units, NPUs.
Or tensor cores.
Right, which are what modern AI models desperately need to perform matrix multiplication efficiently. Furthermore, even with LPDDR4X, large language models will just instantly saturate the memory bandwidth.
It just hits a wall.
Yep. If you suffer from infrastructure blindness, you might waste weeks trying to force a complex deep learning model onto hardware that is fundamentally bottlenecked at the architectural level.
They also cover remote management optimization, comparing the new Raspberry Pi Connect service, which I think is integrated directly into Raspberry Pi OS 12, versus the traditional real VNC setup.
It's all about finding the most efficient, least resource-intensive way to access your devices.
So, what does this all mean? What connects all of these seemingly disparate topics? Whether it's saving memory overhead on a minimal operating system, understanding the bandwidth bottlenecks for edge AI, or avoiding 6 hours of wasted IEM troubleshooting in AWS.
It's the core value of holistic understanding. It is the practice of knowing the exact limitations, boundaries, and rules of the environment your code lives in.
Bringing this all together, it really forces you to examine your own daily workflow. The real skill set we are talking about today isn't just about how flawlessly you can write a Python script or configure a JSON file.
No, it's about understanding the entire ecosystem surrounding that code. A brilliant, hyper-optimized piece of code running on a Raspberry Pi 5 is going to crash if you don't respect the hardware's AI limitations.
Just like the S3 bucket.
Exactly. A perfectly configured, beautifully architected S3 bucket is going to fail if you don't respect the administrative and billing status of the AWS account. The ecosystem dictates the success of the code.
Whether that ecosystem is a $50 tiny Internet of Things device sitting on your desk, or a multi-million-dollar server farm powering a global enterprise, the rules still apply.
They absolutely do.
So let's distill the ultimate big idea from Aaron Rose's breakdown, the absolute core takeaway you need to burn into your memory. When your terminal throws that 403 account problem error, you need to take your hands off the keyboard.
Step away from the code.
Stop looking at your S3 bucket. Stop checking your IAM permissions. Stop reading your code. You need to look at the AWS account standing.
Verify the account status. Check the administrative hub for billing notifications. Look at the AWS Health dashboard for system-wide flags. And, make sure you are actually operating under the correct credentials.
The answer is almost always sitting quietly in the administrative layer, completely separated from your engineering work.
Exactly.
The entire goal of this deep dive was to equip you with an aha shortcut. We want you to be the hero in your company's Slack channel.
Oh, everyone loves that person.
Right. The next time you or your team hits this exact frustrating wall, You aren't going to panic. You aren't going to let 4 different engineers spend the entire afternoon rewriting deployment scripts.
You are just going to calmly ask, hey, did the corporate credit card expire?
And you are going to save everyone hours of agonizing over perfectly good code.
It is incredibly empowering to realize that not every error message you face as a developer requires a software engineering solution. Sometimes the best debugging tool is just knowing who to ask in the accounting department.
That brings up a final, slightly provocative thought I want to leave you with.
Okay, let's hear it.
Since we now know that mundane administrative issues like a blocked credit card, a flagged transaction, or an unverified email can trigger these obscure code-breaking technical errors, what does that mean for the future structure of tech teams? Will the evolution of software development require a completely new hybrid role? Something like DevOps.
DevOps. Bridging the gap between corporate finance and site reliability. I mean, it makes a lot of sense. If the business layer can break the technical layer without any warning, the technical team fundamentally requires visibility into the business layer.
Imagine a world where engineers must have real-time, automated access to corporate billing, health, and account statuses just to ensure their applications don't mysteriously crash in the middle of the night because, I don't know, a bank fraud algorithm flagged a server renewal fee.
It's a whole new frontier of system architecture.
It really is. Something to mull over the next time you're staring down a 403 error. Remember, sometimes the problem isn't your code. Sometimes the city just foreclosed on the building.